Welcome back, Year 13s. In today's explainer, we're exploring an absolutely fascinating biological mechanism in social cognition. It's perfectly aligned with your AQA specification. We're going to be looking at the mirror neuron system. This is a biological network that might just explain how we automatically understand the actions, intentions, and even the emotions of the people around us.
But before we really get going, I want you to cast your minds back to our previous work on biopsychology and brain localization. Remember how specific areas of the brain are responsible for specific functions? Well, keep that hardwiring of the brain in your mind, along with our early social cognition theories. Because today, we're taking that really concrete biology and we're applying it directly to the wonderfully messy, complex world of human social behaviors. We are literally bridging those two worlds together.
So, here's our roadmap for the explainer. It's structured exactly how you'll be assessed in your AQA exams. We'll move from AO1 core knowledge into AO2 application and then AO3 evaluation. And finally, we'll wrap up with a stretch challenge, a short quiz, and a quick practical study.
All right, let's dive straight into AO1 and look at how this remarkable system was first discovered.
Now, for your AO1 marks, you absolutely need a precise definition. The mirror neuron system, or MNS, is a network of neurons that fire under two very specific conditions: when you perform an action yourself and when you observe someone else performing that exact same action. So the brain literally mirrors the behavior it observes. It creates this powerful internal simulation of what the other person is doing, and it does all of this without you moving a single muscle. It's a really incredible piece of biology.
To really grasp this, we've got to look at the timeline of the evidence. And it actually starts with one of the most famous accidental discoveries in modern neuroscience. In the early 1990s, Giacomo Rizzolatti and his colleagues in Parma, Italy, were researching the premotor cortex, specifically area F5, of macaque monkeys. They had electrodes hooked up to monitor the neurons responsible for hand and mouth movements. Well, the legend goes that during a break, a researcher walked into the lab eating some food, maybe a peanut or an ice cream. And as the monkey watched the researcher grasp the food, its motor neurons suddenly began firing wildly. The monkey wasn't moving, right? Just watching, but its brain was reacting exactly as if it were performing the action itself. Now, moving on to humans. Because we can't ethically use invasive single-cell recordings in people, researchers had to turn to neuroimaging. In 1999, Iacoboni used fMRI scans to show that observing and imitating facial expressions activated overlapping cortical areas in the human brain. And then, in 2005, Iacoboni took it a step further. He demonstrated that this system doesn't just mirror basic physical movement, it actually helps us understand action intentions, like determining whether someone is picking up a cup to drink from it or picking it up just to clear it away.
Watch how I break this down logically for an exam answer. Step 1. You observe a goal-directed action happening right in front of you. Step 2. Neural mirroring instantly occurs in your premotor cortex. Step 3. Your brain creates an internal simulation, essentially playing out the motor commands almost as if you were performing the action yourself. And Step 4. And honestly, this is the absolutely crucial part. Because of this simulation, you can instantly and implicitly infer the other person's intention. It's a completely automatic process that happens in mere fractions of a second.
So, collectively, these neural processes form the biological foundation for several massive aspects of human social cognition. First up is imitation learning. The MNS gives us a direct perception-action matching system so we can effortlessly copy others. Second is empathy. This shared circuit allows us to internally simulate and therefore genuinely feel other people's emotions. Third is intentionality, which we just touched on, guessing the hidden goals behind actions. And finally, some evolutionary theorists even suggest it's the foundational basis for human language. Think about how much we still talk with our hands and use gestures today. The MNS might have actually bridged the gap between physical gesturing and verbal communication in early hominids.
For your specification, you also really need to know the broken mirror hypothesis. Proposed by Ramachandran and Oberman in 2006, this theory suggests that the social and communication differences we frequently see in autism might actually stem from dysfunction within the mirror neuron system. Now, please remember to emphasize the word hypothesis here. The core idea is that an impaired MNS leads to challenges with imitation, empathy, and mentalizing simply because that low-level automatic neural simulation isn't occurring typically. But we have to remember that autism is highly complex, and this is just one theoretical biological lens through which we try to understand it.
Now let's transition smoothly over to AO2 application and exam skills.
So have you ever automatically winced, maybe even grabbed your own hand, when you saw a classmate trap their finger in a heavy door? Or notice that you instinctively smile back when a stranger smiles at you?
Well, that is automatic micro-imitation, and it's driven directly by your mirror neuron system. It's also exactly why you can improve a complex physical skill, like say a basketball free throw, simply by watching a teacher or a professional model it. As you watch the ball leave their hands, your brain is running a silent practice rep right in your own motor cortex. You're rehearsing the movement neurologically without moving an inch. Pretty cool, right?
Let's look at a research methods-linked AO2 question. Imagine you get this scenario in an exam. A researcher wants to study MNS activation while participants watch a basketball free throw. How might they operationalize this using an EEG? I want you to pause the explainer right here for just a moment. Think about how you would actually measure this invisible internal mirroring process in a strict laboratory setting.
Okay, got your answer? Let's break it down together. To secure those top application marks, you have to be incredibly specific. Step 1 is simply identifying that an EEG measures electrical activity in the brain. Step 2 is explicitly stating that you would measure mu rhythm suppression. This is the specific EEG brainwave pattern that's linked to motor activation and mirroring. And step 3 is linking it directly back to the stem of the question. You must clearly state that you would record this mu rhythm suppression while the participant is actively observing the basketball free throw video.
And here is a really brilliant synoptic link to your biopsychology unit to help elevate your essays. The human MNS primarily involves the inferior frontal gyrus, the premotor cortex, and the inferior parietal lobule. Now, if you mention these specific anatomical regions in an essay, you are showing the examiner that you truly understand the localization of function for action planning. You're proving you know exactly how that hard biological structure directly underpins our fluid, everyday social behavior.
Let's shift gears now to AO3, Evaluation and Debates.
As A-level psychologists, it's your job to weigh up the evidence critically. So on the strength side, the MNS theory has incredibly robust neuroscientific support from fMRI, MEG, and EEG studies. They all consistently show overlapping activation during observation and execution. It also possesses really high face validity. I mean, it intuitively makes perfect sense of why we flinch when others are hurt, or why yawning is contagious. However, it definitely faces some very significant limitations. First off, the evidence in humans is entirely indirect. Furthermore, that broken mirror hypothesis for autism we talked about, it is currently heavily debated in the scientific community. The results are highly mixed. Many autistic individuals show completely typical imitation skills and typical mirror rhythm suppression, which means the theory just cannot fully explain the condition.
Now, please pay close attention to this misconception alert, because examiners see this exact mistake every single year. Students will write in their exams that human mirror neurons have been directly observed. They absolutely have not. Due to strict ethical boundaries regarding human research, we just can't perform invasive single-cell recordings in humans like Rizzolatti did with his monkeys. Therefore, all of our human evidence comes from brain scanning. This means our evidence is entirely indirect and correlational. We see overlapping blood flow or electrical activity, sure, but we cannot definitively prove it's the exact same individual neurons firing. So please keep that critical distinction clear in your mind.
For your issues in debates marks, you should definitely argue that the MNS leans heavily toward biological reductionism. This theory attempts to reduce highly complex, deeply felt social phenomena, things like emotional empathy, compassion, and intention reading, right down to the basic firing of motor neurons. But a more holistic evaluation would point out that true human emotional empathy involves much wider networks, including the limbic system and the prefrontal cortex. The MNS is really just one biological cog in a much, much larger psychological machine.
Now for a quick stretch and challenge. I want you to reflect conceptually on this. Is mirroring the absolute root cause of our empathy, or is it merely a biological byproduct of a higher-level cognitive system, like theory of mind? In other words, do we physically mirror people because we're already cognitively empathetic, or does the physical mirroring force the empathy into existence? Take a moment to think deeply about how biological hardwiring and cognitive thoughts interact here.
Excellent focus so far. Let's move on to a rapid retrieval quiz to consolidate your core knowledge before we finish up.
Here are your 3 questions. Question 1, who discovered the MNS in the early 1990s using macaque monkeys? Question 2, what specific EEG pattern indicates MNS activity? And question 3, what is one major limitation of human MNS research? Pause the explainer here to test yourself. Okay, ready? Let's check your answers. Number 1 is Rizzolatti and his research team. Number 2 is mu rhythm suppression.
And number 3 is the ethical inability to conduct single-cell recordings in humans, which means all our scanning evidence is purely correlational.
Now, to see this biological theory in action, try this highly ethical classroom practical. It requires absolutely no equipment and relies on pure observational research methods. Working in pairs, have one student perform a spontaneous, natural-looking yawn or a sudden smile. The other student, acting as the researcher, should use event sampling to simply tally any instances of automatic micro-imitation in their partner's face. It's just a fantastic, immediate way to observe automatic perception-action matching occurring in real time right in front of you.
So to summarize today's learning, for AO1, remember the definition and the dual activation pattern of the MNS in the premotor cortex. For AO2, be prepared to apply this to imitation learning, automatic empathy, and definitely use mu rhythm suppression in your methods answers. And for AO3, while it offers a really strong biological basis for social behavior, remember to evaluate it critically as biologically reductionist. It's just one part of a much broader neural network. Fantastic focus to the year 13s. I'll leave you with this final provocative thought. If our brains are biologically hardwired at a cellular level to instantly mirror the actions, intentions, and feelings of others, where do the people around us end and where do you begin? Keep reviewing these concepts, and I'll see you in the next explainer.